Welcome to a third Energy Engineers webinar on eliminating peak demand charges and the second part of our Back to Basic webinar series. Today we will explore strategies and practical solutions for eliminating peak demand charges, power factor charges, and exploring variable energy pricing. In today's world where energy costs and demand are increasing and the environment is becoming more and more a concern, optimizing energy efficiency is paramount. By implementing effective measures, we can reduce our carbon footprint, but also save costs. Today, we're going to talk about energy efficiency fundamentals, business implications, key strategies, solution examples, overcoming challenges and barriers, and the future of energy efficiency. Energy efficiency fundamentals. Peak demand charges. Some of us may have seen them on the electricity bill. What are peak demand charges? Peak demand charges on your electricity bill are additional costs incurred for the highest rate of electrical power usage in a specific period, measured in kilowatts. It's important to distinguish this different kilowatt versus kilowatt hour. Unlike regular usage, demand charges are based on the total electricity consumption, kilowatt hour. Peak demand charges, however, cover the utilities cost for maintaining the capacity to meet high power demands. This encourages users to distribute their electricity usage more evenly, reducing strain on the grid. It is a capacity charge more than anything else. There is little that can be done practically to avoid this charge, other than changing this peak usage. Power factor charge. Some of us may be more familiar with this one. What is a power factor charge? A power factor charge in your electricity bill is a fee applied when electrical power is used inefficiently in your business. Usually, when your power factor is less than zero point 0.8, this charge is charged on your electricity bill. Power factor is a measurement of the efficiency of your electrical usage. A value of less than 1 indicates losses in your system. These losses are created by inductive and/or capacitive loads. These are all loads except for resistive heaters or incandescent lights. Power factor is a subset of energy quality. The only thing that can resolve a less than ideal power factor is to apply a power factor correction, be this with a power factor correction unit or by installing equipment with a better power factor. Energy quality. What is energy quality? Energy quality in an electrical system refers to the consistency and the purity of the power supply, encompassing aspects such as stable voltage levels, frequency consistency, power factor, and disturbances such as voltage spikes, dips, harmonics, and electrical noise. Poor energy quality can lead to inefficiencies, increased operational costs, and the risk of damage to equipment. There are steps that can be taken in regards to energy quality, but we'll leave this for another webinar. Energy measurements. Not a new technology, but in the last couple of years, its capacity and its ability has improved significantly. But what is energy measurement? Energy measurements quantifies the energy consumption at a business, primarily recording in kilowatt hours. However, it can also include additional parameters such as voltage, frequency, power factors, and other aspects of energy quality. The duration of these measurements can vary, extending from instantaneous reading to continuous and permanent recording, and everything in between. The granularity of measurement ranges from broad gauge metering to the precise metering of each individual load connected within the premises. The range of energy measurements extend from simple kilowatt-hour meters to sophisticated systems offering live data and real-time graphs. that track energy usage over time. We can perform all these types of energy measurements, but we'll leave this for another webinar. Business implications of peak demand and power factor charges. Some of these implications are unnecessary increase of operational cost. Peak demand and power factor can be completely avoided, and the charge is by design for businesses to fix this issue. Potential overload of infrastructure. If the infrastructure of a site is designed for the maximum demand of a site, it may not be designed for such high loads or power factors, leading to voltage drop and unnecessary heating in motors and cables, generally increasing energy demands. Great potential for energy efficiency improvement. These charges can be fixed in most occasions and will lead to reduction in operational costs. If you have these problems, please book that free 15-minute consult on our website. Key strategies for improving peak demand and power factor charges. In simple terms, the peak demand can be moved or removed depending on a situation. Solar PV to offset peak demand during daylight hours. Battery to move the peak to the shoulders of the day. Changing machines to more efficient type, for example, using heat pumps rather than resistive heaters. Heating or cold storage, or even compressed air storage. Other infrastructure upgrades. A power factor that causes additional charges can be fixed in various ways. Replacing the worst equipment with a better power factor. The application of a capacitor bank, capacitor banks, and passive filters. Both passive and active power factor correction units will improve your power factor. Active power factor correction units will also improve your harmonics. More on this in other webinars. Another fix is introduction of variable speed drives. The power factor of VSD is usually better than an electric motor, especially those not running on full load. Another option that you can look at is renegotiating the peak demand and price of energy with your supplier, and or move to market pricing based on energy suppliers such as Energy Locals and Amber Energy. Solution example to both peak demand and power factor charges. The first step is always energy measurements. As the old adage goes, if you can't measure it, you can't manage it. The energy measurements by the energy retailer is wholly insufficient for understanding the situation at a business. As such, to understand the situation, a high quality broad range energy measurements need to be undertaken and potentially individual measurements of machines. Now that you have your measurements, it's now time to make a plan with an energy expert. The data from the energy measurements need to be examined to understand the source and the sources of the peak demand or power factor. From here, a plan can be designed and is made by an engineer as to how to best fix the peak demand or power factor issues based on particular sets of situations within the client's facility. Implementing changes. Here's where the rubber hits the road. This is probably the more disruptive part of the process. Here is where the solution to peak demand and power factor solutions will be implemented. Peak technologies to move or remove peak demand, energy storage, energy efficiency upgrades, and or power factor correction solutions. Yes, power factor correcting can lower your peak demand. The next step is monitoring energy demand and power factor. After the changes have been implemented, it is important to test that the implemented changes have been sufficiently implemented and that it stays sufficient over time. We generally advise permanent energy measurements and monitoring of most installations to prevent problems in the future and finding issues with machines before they cause machines breakdowns. Our slogan, Measure, Correct and Monitor, as this is the process to fix most energy efficiency and other energy problems. This is what we found in most cases: measure, correct, and monitor. Please book a 15-minute consult if you want to know more about energy measurements and how this can solve not just your energy efficiency but also other energy problems. Overcoming challenges and barriers. There's always those unscrupulous operators, business that would just sell you their solution without performing energy measurements or providing a whole of system solutions, only just a band-aid. Then there is wrong technology implemented. When the approach does not fundamentally address the problem, but rather a solution to a symptom, the problem has not been fixed and will appear again. The outcome in these circumstances is malinvestment and could even make the problem worse. Then there is insufficient investment into the problem. When a problem is only lightly touched, then the problem may only be partly solved, or not at all. The problem here is that the money spent on a problem may not be recovered in the future. Then there is subsequent changes after the fix have been implemented. If a solution is selected, implemented, and solves the problem, if then a change happens to the system, this may make a new problem or the old problem potentially reappear. The future of energy efficiency, or as it applies to the charges we've been speaking about. One device that does it all. We foresee a future where a single device performs the task of solar inverter, energy storage, dynamic power factor correction, and energy quality. The current equipment is technically already able to do this, it just isn't implemented as such. A good example here is the hybrid inverter, where solar PV and battery is in one device. Now, the problem with all the one device that does it all is it works well in some occasions, never perfect in all occasions. Energy storage. A hot topic currently is energy storage, be it in batteries, compressed air, or be it in heat and cold storage. These are concrete solutions to moving and reducing energy usage from the grid. It enables you to buy energy when the grid demand is low and use the energy in the form from the batteries, compressed air, or heat or cold on a later stage. Another important development is dynamic power factor correction, a technology that has been around for a little while that uses reverse energy to correct power factor or harmonic distortion. These devices even do a degree of fixing uneven loaded phases to a degree. And then we have more efficient solar PV and batteries. More efficient solar panels and batteries are always around the corner, where even more energy can be generated at cheaper cost than buying it from the grid. This is already the case, where energy generated on site is cheaper than that from the grid. But as efficiency of solar PV and batteries increase and the cost decrease, this becomes even more so a factor. Then, and last but not least, is market pricing for energy and prosumers. This is already happening with energy locals or Amber Energy that are offering market pricing for energy. In the future, changing when using your energy will impact your bottom line. What this means is a pricing structure for energy usage that's not a flat rate, but rather based on availability in the grid. Thank you for your participation in this webinar, focusing on peak demand and power factor charges. We hope you found this webinar insightful and that it aids in your decision making as you embark on your journey towards energy efficiency, ultimately leading to savings on your energy costs. Should you have any questions, we invite you to fill out a contact form on our website or book a 15-minute online consult. Our team usually responds within 24 hours. If you have any requests for future webinars topics, just drop us a line. Thank you and goodbye.